Utility companies, also known as POCOs, often mandate specific equipment configurations which can present challenges during electrical installations. These challenges frequently revolve around insufficient space for wire terminations within the mandated equipment. Firstly, let's look at CT enclosures. Current transformer, or CT, enclosures are often positioned adjacent to sizable disconnects typically rated for 400 amps, 600 amps, or even higher. However, the physical dimensions of these enclosures might not provide ample room to facilitate neat and, more importantly, safe wire terminations. Installers frequently encounter difficulties when attempting to make connections, leading to potentially hazardous situations if not handled properly. This is often exacerbated in underground feeds where installers must loop wiring from underground up to the top terminals and then back up from the bottom to reach the disconnect. The lack of space makes it difficult to make proper bends and secure terminations. A common utility requirement is terminating conductors at the top of CT enclosures. This requirement persists even when the termination point doesn't serve as a true disconnect. In these situations, the top termination mandates can create significant spatial challenges. This is particularly true when looping wires from an underground source through the CT enclosure and subsequently connecting them to the disconnect switch. The available space becomes even more limited, leading to potential code violations if the conductors aren't properly managed or supported. Another challenge involves the connection space in transformers. Transformers can present their own set of spatial challenges. The physical layout often provides ample connection space on the primary side, especially when dealing with relatively small high-voltage cables such as a 1/0 cable. However, the secondary side, when numerous large conductors like 350 kcmil or 500 kcmil cables must terminate, frequently suffers from severely limited space. Imagine transitioning from a spacious area for a single primary cable to a cramped area where you need to terminate anywhere from 16 to 44 large secondary conductors. This disparity can lead to significant installation headaches and potential safety concerns. So, what are some potential solutions to these problems? One approach involves direct engagement with the relevant power company. Communicate the spatial constraints encountered during installations and formally request modifications to their equipment specifications. Specifically, suggest incorporating bottom feed lugs into CT enclosures or expanding the overall dimensions of the integrated wireways. Direct negotiation with the power company represents another avenue for resolving spatial challenges. Engage in open dialogue to explore alternative solutions that align with their operational requirements while offering enhanced installation flexibility. Examples of such alternatives include using physically smaller CT or relocating the CT enclosure to a more accessible and spacious location. Exploring equipment alternatives from different manufacturers can yield valuable solutions. Conduct thorough research to identify enclosures with side feed wireways or transformers with generously sized connection spaces. These alternatives can significantly simplify the installation process and improve overall safety. When faced with seemingly insurmountable spatial limitations, improvisation can become a necessary tactic. This involves creatively adapting the available space to accommodate the required connections. Techniques such as custom bending conduit, employing cable organizers, or utilizing other space-optimizing devices can help maximize the use of limited space. Now let's consider some of the underlying reasons behind the prevalence of insufficient space in POCO required equipment. Firstly, legacy standards are a factor. Some equipment designs might trace back to historical standards that don't reflect contemporary industry practices. These older designs might not adequately address the spatial needs associated with modern electrical installations. Secondly, safety concerns are paramount. Power companies prioritize safety and often enforce strict clearance and separation distances to mitigate potential hazards. These safety measures, while essential, can inadvertently contribute to space limitations within equipment enclosures. Thirdly, cost considerations often influence design decisions. Equipment manufacturers may prioritize cost-effectiveness over space optimization to maintain competitive pricing. This can lead to compromises in equipment dimensions and internal layout, resulting in limited space for wire terminations. Finally, lack of feedback from installers can perpetuate the problem. Power companies may not receive sufficient input from installers regarding spatial constraints encountered during real-world installations. This lack of feedback can hinder the identification of design flaws and impede the implementation of necessary improvements. In summary, dealing with an adequate wire termination space in POCO equipment is a common challenge. By understanding the possible solutions and reasons for the problems, electrical professionals can make better decisions and improve safety during installations.